trial and error works very nicely when your a coefficient in front of your x squared term is 1. Because it's very easy to figure out how you're going to set up your parentheses. But let's talk about how the box method works. Okay? The box method says figure out what a times c is. Well, a times c is what? Remember, this goes ax squared plus bx plus c. Okay? I got nothing from you guys, so I knew something was wrong. Okay? All right. So a times c equals 20. Okay? That's what we're looking at. And we want factors here. And they have to equal what we want here is what our b value is, which is negative 9. So if what I multiply together is positive, but what I add is negative, then I know that both of my factors must be negative, right? A negative times a negative is a positive, and a negative plus a negative is a negative. So negative 4 and negative 5, when I multiply, gives me positive 20, and when I add, gives me negative 9. So I know that that is my correct factors that I want to use. Okay? So in our squared, we're going to put our ax squared here and our c here. So here I'm going to put 1x squared, and here I put 20. And in these two diagonals, it really makes no difference, but all I want to do is put in my factors here. My factors that work here times x, and my factors times x. And so what I'm going to put here is maybe negative 4x and negative 5x. All right, you want to pay attention to this part and this part. Okay? Any negative values as we go up or to the left, in other words, since this is negative here, what we're pulling out is a negative value. Okay, what's common between negative 4x and 20x? I'm going to pull out a negative 4. I cannot pull out an x because x doesn't occur in both of those terms. But 4 is a factor of 20, and 4 is a factor of 4. It's negative because this one is negative. If it's positive, then I pull out positive. But if it's negative, I pull out a negative. Okay? And we're always going up or over. Okay? All right, what do I pull out between 1x squared and negative 5x? First of all, is my answer positive or negative? Because 1 is positive, right? So between x squared and negative 5x, what do I pull out? Okay. Now going right to left. What do I pull out between 1x squared and negative 4? Is it positive or negative? And it's x. And between negative 5x and 20, positive or negative? Negative 5. Therefore, my factors are x minus 4 and x minus 5. Now, that's easy. You could have figured this out without using the box method, but let's do the box method on the easy ones so that when we get to the harder ones, they make more sense. Okay? All right, so x squared, negative 12. What are my factors of negative 12 that give me positive 3? If I want to multiply to get negative 12, that means one of my values has to be positive and one of them has to be negative. But remember, when I add them together, I want 3. So I could do negative 1 and positive 12. But what do I get when I add those? 11. And that's not what I'm looking for, right? I could try 3 and 4. But that would give me 1, right, if negative 3. Or it would give me negative 1, right? So try 2 and 6. If the 2 is negative, then we get 4. Any other factors of 12? So this one's not factorable. Non-factorable. Now, one thing that I forgot to tell you is that the first question that you always want to ask yourself is, can I pull anything out? That's a form of factoring. To be able to pull out a value or a variable is a form of factoring. I can't, right? Okay. All right. Can I pull anything out here? All right. N squared positive 9. My product is 9. My sum is negative 3. Well, my only factors of 9 are 1 and 9, which gives me 10, or 3 and 3, which gives me 6. Nope. Nope. NF. NF. Well, this is 4, 3. No? Just parabola. Okay, here we go. Q squared negative 100. What is my product going to be? Negative 100. What is my sum? Which one? Yeah, if it's 1, if you're telling me 1, then I've got 1Q. I've got to have that term there, but I don't have a term, right? So the only thing I can add or subtract is a 0. Make sense? So product of 100, that gives me, negative 100, that gives me 0. Right. So negative 10Q and positive 10Q. Nope, doesn't. Pulling up on the right side, what do I pull out? A negative 10, right? And why is it negative? For me, the way I set up my diagonal, this one is negative, right? You might have flipped them, and you might pull out something else. All right? They're going this way. On the left side, what do I pull out? Between Q squared and 10Q. Going right to left, what do I pull out here? And here? And so what are my factors? Remember, this is called what? It is factoring, but look at your answers. And look at how it was presented to you. This is a special case. It's called the difference of perfect squares. You want to make sure you notice difference of perfect squares has only 2 terms. Both terms which are squared values. Isn't 100 a perfect square? Isn't Q squared a perfect square? Okay. Difference means the sign in between is negative. Why is this one not the difference of perfect squares? Because it's addition. How would you factor this? So remember, that gives me 20 as my middle term. If I do x, if it's x minus 10 and x minus 10, then it's negative 20x becomes my middle term. See, I can't factor that. They're perfect squares, but because I'm adding in between, there is no way to cancel out your terms. One has to be positive and one has to be negative, and we can't achieve that without creating a middle term. Okay? Sure, of course. Not factorable. This is not factorable, and about half of you will want to tell me that x squared plus 100 is factorable. Because you see they're both perfect squares, but it has to be the difference. You have to show subtraction between those perfect squares. Okay, Riley? Sure, right, yeah. Okay, look at this one. All right, this is y squared and 64. My product is 64, and my sum is 16. What's the product of 64 that when I add gives 16? This is a type of perfect square, yes. When I factor, what do I pull out? Here, what do I pull out? Here, what do I pull out? Here, what do I pull out? And here? And so the factor is y plus 8 and y plus 8, right? Which is y plus 8 squared. This is another form of perfect square. This is a perfect square that allows you to have a middle term. This has a middle term. The first term is squared. The second last term is squared. The middle is the sum of those two squares. Okay? You can just use a parentheses. I'm just showing you the box method. What is this one supposed to be? I don't know. Wow. Where did it go? Okay, we'll come back. That's what happened to updates. Oh, do you? Oh, there's that one. Oh, okay. Hold on. I don't, but that's still kind of weird, whatever happened here. We'll come back to it. Okay. So, hold on. Do you agree that this is a perfect square? This is a perfect square? What are the factors of 81? And will those give me this? Negative 9 and negative 9, right? So this is W minus 9 and W minus 9. They have to be the same. If one is positive and one is negative, the middle term drops out. Those are called conjugates. Conjugates. So what I want you to write is W minus 9 quantity squared. Abigail?
So the other one is not because it's just
No, it's a perfect square also. It's y plus 8 and y plus 8. Look. No, difference of perfect squares when there's no middle term and you're showing subtraction. And these will be conjugates. These are called conjugates because everything is the same except for one has a positive sign and one has a negative sign. Yes, Madeline.
on a test, if we write W
Mm-hmm.
is that always rather than put the specific term, we have to say
Mm-hmm. Yep. Okay, what is this supposed to... No. What is this supposed to say?
R says negative 30 space y equals x squared something. That's what it says up there.
I don't have...
We have another one though.
You got that one? What? I have no idea what that's doing there. So it's this one? But I don't know where that negative 30 came from. So we're going to look at y is equal to x squared plus 5x minus 14. When I'm asking for the zeros, and I do want you to know this, that is a solution to the equation when y equals 0. I will ask you, what does it mean to find the zeros? You will tell me it means to find the x values when y is 0. And if y is 0, the x values that I'm finding are called the what? If y is 0 and I want to graph this and I come up with an x value, they are called the y is 0. Solution to the equation when y equals 0. You're finding your x-intercepts. You're finding where the graph crosses what? The x-axis. X-intercepts fall on the x-axis. Y-intercepts fall on the y-axis. That's why they're called y-intercepts. Okay. Well, this is a what? What is this a form of? But what is it the shape of? It's a parabola. Why do we know it's a parabola? Because it's a squared. Okay? And if I find the x-intercepts, haven't I been doing this on the board? It's intercept form, right. So this factors, anybody know what this factors to? X minus. All right. And how do you know that? Because this gives me negative 2x and this gives me 7x, which gives me 5x as my middle term. Right? So that means if this is equal to 0, then what does x equal? A negative 7. X is equal to 2. And if I had to graph that, I know that my graph is crossing at 2 and at negative 7. I know that my y-intercept is. Where's my y-intercept? Well, how do you find your x? It's negative 14, right? Isn't the standard form? Isn't the standard form? Where's your y-intercept? Negative 14, right? No, but and how do I figure out where my vertex is going to be? The midpoint, right? We just did this, right? What's 2 plus negative 7? Well, it's negative 5 over 2. So we know that somewhere between 2.5 is going to fall my vertex. And is this going to point up or down? Up, because x squared is positive. And how would I find the corresponding y value? We know that x is negative 5 halves. How do I find the corresponding y value? You just did this. No, that's my x, 2.5. Plug it in, right? You plug it into the equation and figure out the corresponding y. Do you see? No, but on a test, I will do that. I will say factor, find the zeros, graph your function.
So it's only for the ones that you say that on because that looks like one of the other regular ones.
Right. All I wanted you to do on this problem was do this. Tell me what x is equal to. I just went further and showed you how all of this ties together. Does that make sense? Danielle? To give you a more accurate picture. You don't have to, but we know that that's where it's going to cross. So which really tells us, oh, our vertex should fall below that value, right? Because if it falls above, well, then we don't really have a parabola. Elaine? Mm-hmm. It's not. I was checking my middle term. I'm saying outside gives me 7x, inside gives me negative 2. Do I get 5x when I add those together? I'm just foiling it and checking to make sure that I get the right middle term. If I was asking you to graph it, that would be the value for your vertex, your x value using your midpoint, right? Because we know what our intercepts are, our x-intercepts are now. So we can find the x value of our vertex, and we can plug it into our equation and find the corresponding y value. Does that make sense? I just went a lot further. So all I'm really wanting you to do is find your zeros. So to find my zeros, I have to factor and set the factors equal to 0. If I'm looking for my zeros, this is what I have to do. What do you notice about this next problem? Not really the difference, but we do know that this is a perfect square and this is a perfect square. And the 10, isn't that a product of 5 and 5? So I could write this as x what? And x minus 5, right? The only value that x can be, the only 0 is when x is 5 because it occurs twice. Sure. If the only intercept is at 1, 2, 3, 4, 5, that becomes, you've just shifted it over. Because if it were to be anything else, I'd create another x-intercept, right? And we know that there's no other x-intercept. Okay. Are we good? Were there any other notes? Did you have any other?